So today's video I'm going to talk about atoms and elements, how to find number of protons, number of neutrons, number of electrons, ions, and isotopes. So let's get to it. Atoms are composed of protons, neutrons, and electrons. So basically, protons and electrons, they both have similar masses and both of them have electrical charges. So the charge for proton is positive and the charge for electron is negative. Whereas neutrons is neutral, it doesn't have charge, so no charge. Elements are defined by the number of protons they possess. For example, atom with 2 protons is called helium. Atoms with 4 protons is called beryllium. So if you look at the periodic table, you will see a lot of elements with some with number on top and below them. How do we understand those number and those element symbol? So let's look at beryllium. Okay, so this is how beryllium is shown on the periodic table. So number 4 is atomic number. It's the same thing as number of proton. And then Be is chemical symbol. 9.01 is atomic mass or mass number. And then beryllium is the name of the element. So keep in mind that the number of electron in a neutral atom is the same as the number of proton, but the number of electron in an ion is going to be different, which I'm going to talk about it later in this video. In the periodic table, it is classified into 3 different categories. So we have metals, nonmetals, and metalloids. So this periodic table already color-coded what is metal, nonmetals, and metalloids. And I want to mention that this diagonal zigzag line is what separates metals and nonmetals. The difference between metals, nonmetals, and metalloids. So metals is a good conductor of heat and electricity, while nonmetals is a poor one. And metals lose electrons when undergo chemical changes, but nonmetal gains electrons when undergo chemical changes. Metalloid is a semiconductor because it has an intermediate electrical conductivity which can be changed and controlled. So metalloid is useful in electronic device manufacture like computers or cell phones. So this summarizes the difference between metals, nonmetals, and metalloids. So the periodic table are also divided into main group elements and transition elements. So main group elements, they tend to have like a more predictable properties based on their position on the periodic table, while transition elements, they don't really have a very predictable properties. So each rows like 1 to 7 here is called periods, while each columns is called a family or a group number. So 1H, 2A, 3B, 3A, 4A, 8A are called groups number. So usually an elements that have the same group number, they would have similar properties, and some of them have group name, which I'm going to talk about in a bit. So group 1A is called alkaline metals and it is very reactive. If you take a piece of sodium and then drop it in water, like even a small piece, it's going to explode. Group 2A is called alkaline earth metals. It is fairly reactive metal. So when you drop a small piece of calcium in water, it's going to react vigorously, but it's not going to explode like sodium. Group 7A is called halogens. It is a very reactive nonmetal, and you usually see it, for example, chlorine. We use it in the pool as a disinfecting agent. And then group 8A is called a noble gas or inert gas. It is really stable. So you usually see we fill helium in a balloon. So another thing I want to point out is that the group's number also represent the valence electron of each element. For example, nitrogen is going to have 5 valence electrons and oxygen have 6 valence electrons. I'm going to talk about this in more details in the next video, but just keep in mind that the group's number also represents valence electron. Ions. In chemical reactions, atoms often lose or gain electrons to form charged particles called ions. So positively charged ions, we call it cations. For example, Na plus, calcium 2 plus. Negatively charged ions, we call it anions. For example, O2 minus, chlorine minus. So this table shows the elements that form predictable ions. Like you will always see oxygen with a 2 minus charge, bromine with a 1 minus charge. So basically halogen will form a minus 1, while group 6A will form a minus 2, group 1A will form a plus 1, group 2A will form a plus 2 charge. For transition metals, the charge will be differ because some of them can form plus 1 or plus 2, and then plus 2 or plus 3. It depends. So another thing I want to mention is that the number of electron in an ion. So number of electron is equal to number of proton minus number of charge. So I will do example and talk about this more later in this video. Okay, so isotopes, atoms with the same number of protons but different number of neutrons are called isotopes. So for example, carbon, it can have carbon 12, carbon 13 and carbon 14 isotopes. Carbon will always have 6 number of protons, but the number of neutrons is going to be different in those 3 isotopes. So isotopes can be symbolized by this way or this way. So X is the chemical symbol, Z is the atomic mass, and then A is the mass number. So another style, X is the chemical symbol and A is mass number. For example, neon, so 20 is the mass number, and then we have atomic mass 10, and then we also have neon 21 and then neon 22. And I can write it as neon 20, neon 21, neon 22. Another things I want to mention is that mass number is equal to number of proton plus number of neutron. So now the summary, number of proton is equal to atomic number Z, number of electron in neutral atoms equal to number of proton, number of electrons in ions equal to number of proton minus number of charge, mass number equal to number of proton plus number of neutron, and then we can also find number of neutrons, which equal to mass number minus number of proton. Okay, so let's do examples. So determine the number of protons and electrons in aluminum and aluminum ion. If you look at the periodic table, you would see that aluminum is written as Al 13 and then 26.98, and then they give you like the aluminum name. So from this, we can know that number of proton is equal to 13, and since this is a neutral, like if we write aluminum in a neutral like this, the number of electrons is going to be equal to the number of protons. So number of electrons is also equal to 13. However, if you do aluminum ion, the number of proton is going to be the same thing, equals to 13, but the number of electrons is going to change. So the number of electrons is equal to number of proton minus number of charge, so equal to 13 minus plus 3 equal to 10. So second example, determine the number of protons and electrons in sulfur and sulfur ion, or we call it sulfide. You can pause for a few minutes and try this yourself. Okay, so looking at the periodic table, this is what we see in sulfur. Sulfur are neutral atoms of sulfur, like just as the number of proton is equal to 16 and number of electron is equal to 16 as well. However, if we do sulfur ion, the number of proton is equal to 16, but the number of electron is equal to number of proton minus number of charge, and then 16 minus 2 equal 18. Another way to find the number of electrons in an ion, you can just look at the positive and the negative. So if it has a positive, it's going to lose electrons, so you take the number of proton minus whatever number here. But if it has a minus, it's going to gain electron, so you would take the number of proton plus whatever number of the charge here. Okay, so some more example. What are the atomic number and mass number for the chromium isotope with 28 neutrons? So looking at the periodic table, we can see that for chromium, it will have number of proton equal to 24, which is the same thing as atomic number. So we've got our atomic number check. How about mass number? So we know that mass number is equal to number of proton plus number of neutron. So they give us 28 neutron and we know proton. So we can find mass number by adding them together. 24 plus 28 is going to be equal to 52. Now another example, determine the number of protons, electrons, and neutrons in nitrogen. So going back to the periodic table, you would right away know that the number of protons of nitrogen is equal to 7. Since this is a neutral atom, the number of electron is also going to be 7. We know that mass number equal to number of proton plus number of neutron. Therefore, number of neutron is going to be equal to mass number minus number of proton. But they did not give us mass number. However, we can find it on the periodic table because mass number is going to be equal to atomic mass. So for nitrogen, the atomic mass is equal to 14.01. So you can round it down to just 14. So the mass number is 14, which means number of neutron is 14 minus 7 equals 7. So try this example yourself and then we can compare the answer at the end. Remember, Z is atomic mass and then A is mass number. Okay, so this is what I got and I hope you got the same thing. If you have any questions, just leave the comment and then I'll get back to you. Okay, so one last thing, calculating atomic mass from percent natural abundances and isotopic masses. So the atomic mass of each element in the periodic table represent the average mass of the atoms that compose that element. So in general, atomic mass is going to be equal to fraction of isotope 1 times by mass of isotope 1 plus fraction of isotope 2 times by mass of isotope 2 plus fraction of isotope 3 times by mass of isotope 3, and etc. Let's jump to example. Rubidium has two natural occurring isotopes, Rb85 with a mass of 84.9118 AMU. So AMU is atomic mass unit. It's the same thing as gram per mole. And a natural abundance of 72.17% and Rb87 with mass 86.9092 AMU and a natural abundance of 27.83%. Calculate the atomic mass of rubidium. So we would use the formula that we've seen. Atomic mass equal to fraction of isotope 1 times by mass of isotope 1 plus fraction of isotope 2 times by mass of isotope 2. So in this case, we know that fraction of isotope 1, which is Rb85, is equal to 72.17 divided by 100, which is equal to 0.7217. And fraction of isotope 2, which is Rb87, is equal to 27.83 divided by 100, which is 0.2783. So we can just plug in because we know mass already. So atomic mass equal to 0.7217 times 84.9118 plus 0.2783 times 86.9092. And we got 85.47 AMU. So what this means is that even though we have two different isotopes, but the isotope 85 is the one that we usually see in rubidium in nature. Okay, so one last example. European has two natural occurring isotopes, EU151 with a mass of 150.9198 AMU and a natural abundance of 47.8% and EU153. Use the atomic mass of European to find the mass and natural abundance of EU153. So we know that the isotope will add up to 100%. In this case, we can find the EU153 natural abundance by just take 100% minus 47.8%. So we can do natural minus 47.8% equal to 52.2%. So natural abundance check. Now we have to find the mass of the EU153. We're going to use the same formula that we just did. So atomic mass is equal to fraction of EU151 times by mass EU151 plus fraction of EU153 times by mass of EU153. So you can just like plug in all the number and then find the mass, or you can just try to isolate the mass first and then plug in the number. So I will just isolate it first. So I would get mass of EU153 equal to atomic mass minus fraction of EU151 times by mass of EU151 divided by fraction EU153. So I can get my atomic mass from the periodic table, which is 151.97 minus fraction of EU151. So 47.8% can be written as 0.478 times by mass 150.9198, all divided by fraction of 153, 52.2%, which is 52.2 divided by 100, so 0.522, and I would get 153 AMU. That's my answer. So that's it about this video. I'm sorry it's a little bit long, but I hope it is helpful. And please remember that your progress is your own progress, and practice makes perfect. It doesn't matter how slowly you go as long as you do not stop. Bye.